Arduino program on
This is the Arduino, the first working circuit. First working circuit which has the LED. LED. We call it LED. And in this one, it has a blinking LED. They're powered by...
Shut up.
That was just them. They're kind
Weird.
of stupid. It's an LED. It's simple as turning on and off, but it's a beginning.
How does it work?
It says here.
Take a picture. Yeah.
First circuit ever.
Can you get a video?
Okay, let's make it successful circuit.
First
Successful circuit. Let's make it so that it's
like the whole.
first
a little video, okay?
successful circuit. It's blinking.
Doesn't make sense.
That's the resistor. Those are the wires. Let's put our face in it. Okay, this is our second circuit and it has a potentiometer right there. And you can actually use this because it has an arrow and you can adjust how fast or dim the lights. As you can see, when we turn it down, it blinks slowly. And then when we turn it up, it blinks
Turn this arrow.
The analog and the digital is in the red one.
We found it tricky with this one because we didn't know we could turn this, so we thought it was wrong. But it was actually really easy.
And we tried to upload it, but then the computer crashed. So then we had to start all over again.
Yeah. But we did it.
Yay.
Okay, see you in the third one. We can show the picture of this one.
Wait, something wrong happened.
It's after the middle. It's after the first. Yeah.
I think you're downloading something.
It's this one with the potentiometer. Exercise number 2.
No, we won't. I guarantee it. I ain't ever talking to you.
And it's not really complex, but you have to be really careful so that you put every single piece in the right place.
Yes. This is the third circuit, which is made using the RGB LED.
It changes colors and it like mixes them so they get unique colors.
So from red, green, and blue, they mix it and you get these.
We also have
All sorts of colors.
We also have 3 resistors,
And they are 330 ohms.
and we also have 6 of these wires over here. And that's basically what this circuit is made of. We had some challenges with the wires because there's so many wires packed in one place.
And especially with this one because you have to pull it out and then put it in the right place.
And the picture of the circuit
-4. Okay.
looks like this.
Here. Down here.
And it's very tightly packed over here, so that was the only challenge we faced.
It's like -4, right?
This is circuit number 4, and you can see that the lights are turning on, like, first this one, that one.
And it's flowing, and it's made of 4 red ones and 4 yellow LEDs, and it has 8 of these 330 ohms resistors, and it has 10 wires. And what's
It's a sequence.
yeah, it's a sequence, and what's very hard about this one is that everything is so compact and you have to keep it as it is because you can see that everything is so tight. You have the resistors, the wires, and the LEDs.
And since it's going on forever, it's probably in a loop.
Yeah.
Look, you can turn it like this. Look.
But it's very nice to look at.
Alright, you go back and check. Also, the other thing you need to check is sometimes, okay, these are really good. They're nice and
Circuit number 5.
This is circuit number 5, and it contains two buttons, 3 resistors, a LED light, and 6 wires.
Here, these 2 resistors here, they're 10k ohms, so 10,000. And this one is 330.
And what happened? They're off, but when you click the buttons,
It turns on.
a blue light and the red LED light.
And if you press both, it also turns off.
What was challenging about this was that everything is again very tight, not very tight together, but the buttons was hard to assemble.
And the first time we tried, we put one of the wires in the wrong place and we had to restart because we thought there was something wrong with the button. So we took out everything. And we almost did that for the second one too.
Sophia,
This is how the circuit looks like.
can you open your circuit board and let me see it in the drop-down menu there? Under tools. What? Tools. Tools, please.
Circuit 5, take 2.
The thing that is special with this circuit is that this one has an input, which are the buttons. So when we push them, something will happen, and the output will be the light will turn on or the light will turn off.
Input, output. This is circuit number 6. And this has a photoresistor, which is this one over here. What it does is when there's little light,
Like here, when I cover it, there's a little light. The
it like dims the lights because it's like it detects
when I
the
take
light.
it off, it makes it brighter again.
See, alright. He doesn't let us do
This is circuit 6.
See, it's low.
And when you take it off, the
Light is higher. The photosensor. This thing.
It never occurred to you that you wouldn't heard it. You wouldn't be.
You can see it really
No, it is.
little, but it works.
now it's dim,
You cannot see it on the video.
and now it's bright.
And this consists of a photoresistor, a 330 ohm resistor, and a 10K resistor,
6 wires and an LED.
yellow LED, and this is really cool.
Kids sometimes, you know, they
Hey,
take
thank
things
you.
the wrong way.
Take 2 for circuit number 6.
This one also has an input. So the input is the photoreceptor. It will take it will see how much light there is in the room, and according to that, it will send an output if it's light in the room.
So this is the input, and the output you can see with the lights.
Output would be that the light will turn brighter and dimmer.
This is circuit number 7, and what it has is a temperature,
That's an awesome feeling.
a detector,
I understand.
and what it does when we are outside and we put this serial Bluetooth thing, what happens is that it detects the temperature sensor because it's a temperature sensor. It also has 1, 2, 3, 4, 5, 6, 7 wires, and that's the only thing that this is composed by. But it actually worked. We went outside just a second ago and tried it, and it has just a temperature sensor and 5 of these here. And this is how the circuit looks like. We can take the other picture so you can see it more in detail.
Okay, so
So you can just see the temperature and the 1, 2, 3, 4, 5 wires. And it worked, and we were able to detect what temperature it was outside.
change your name on that.
This is circuit number 8.
And it has a servo motor which spins
Do it now.
at different
Diego, do
speeds.
it now. No.
It has, how many wires does it have, Vedangini?
Diego, do it now.
8.
8 wires, and it has the servo motor.
Okay, where are we over here?
And it works like this, that it's connected with this
Take the board out and flip it around.
to the circuit, which goes back to this.
Black goes with black, red goes with red, and white goes with orange.
It's right. No. See, it's the same way as ours. It's the same way as ours.
Okay, then.
Yeah, you can read both ways. You can read here, and then you can read
As long as you read.
This here is circuit number 9.
It has a flex sensor, this one over here, the long thing, and it has a servo.
And it has a resistor, 330, and it has 10K, and it has how many?
11 wires.
11 wires. And what this does when you shake it, this moves.
And it does it like if I
Diego,
bend
did you change
it,
your name?
Did I?
I don't know, I'm checking
and
now.
then like this.
See?
Is this 10 or
Yes, thank you, Diego.
30 volts?
It's very cool. The challenge with this one was that it is again very much wires. It just keep on getting more
Let's say
complex.
thank you.
But the thing was maybe like finding them. But this works very well and it's really cool.
This is a soft potentiometer slash soft pot, and it's a kind of variable resistor. And when you touch a point on that, the LED will change the color, and it's a RGB LED, so it has different colors.
And it consists of LED, 330 ohm resistor, and 10,000 gauge resistor, and the wires, and this up potentiometer.
Wait, what? The code for delaying for half a second is delay.
And the input is
500 in bracket.
This, like where you touch it, and how many.
and the output is here.
Milliseconds is
Okay,
1,000
files.
seconds, so
Input.
Examples,
Men det står ikke sekunder.
Okay, I have no idea.
There we go.
Okay,
Dude,
so
connect with them.
This one.
where is this going? It has 2 points.
712.
GND plus GND top. Oh, so is this.
It's not remaining.
This, the minus. I put this in the wrong place. I took the. This is not going there. This is going somewhere else. This is going at 9. This is going here and at the bottom.
You have the honor to the last one, and then I need to do the SIK code thing.
Okay, wait. F9, F7. Where's F9?
Anyway, how much is it?
5 minutes.
Should I show you the text? He sent me. No, he sent me text.
Why is this not going in?
She wants to get video playing on the
There.
Now we have to plug it in,
Ever? No, don't.
I hope we've done the correct thing.
or else it would be really awkward.
Give me an LED.
Why is
I haven't plugged it in this yet.
Give me. Why are you not
How?
Because I'm working with it. Why are you not giving me the LED?
Oh.
Why are you not giving me the LED?
Vedangini. I haven't even uploaded it. Shut up.
Diego, please.
No, guess what it requires? Guess what it requires?
Wow.
Programs to
Okay, it's done uploading.
Development kit?
Java developmental kit.
It'll take forever.
I was hoping that.
Why doesn't it play?
Just
Play music.
Okay, maybe it's in the wrong place.
Maybe you broke it, Vedangini.
5, 7, 5,
You go
9.
on java.com
I mean
and then
F7,
it takes forever
F9.
to find it, but I can find it. And then you download it and then it takes like 1 hour.
Yeah, but
No, not there.
that's stupid.
7 and 9.
No, what? Yes, because I was holding it and you put it.
Guys,
Yeah.
Why are you
Okay,
not
I'm
working now?
I'll work on this like next. And I mean, not
No, but you need to install it now.
Why isn't it working? It just
Oh, we
worked.
have to rotate it slightly. That's what they say.
How this work?
What do you mean rotated
It's
slightly?
not gonna go faster on my computer. The internet.
Yeah, no, because for some reason on personal computer, it seems to need the development kit and stuff.
Yeah, but that's because they never update their Java.
Why?
Oh, yeah.
No
They don't
working.
update Flash.
Yeah, because you get that
And
actually.
it's really annoying.
Can't
sometimes.
rotate it, just worked.
Yeah, we couldn't. It's like
Flash left the first one.
Is it in the right place?
I don't even know. 7 is fine. So it looks like this.
I said, can I read? Am I color?
It worked.
Oh look, it's a Swedish color.
So I think we should make a red.
Oh my god, you guys are my colors anyway.
What's wrong with this thing?
Which one is that? No.
Circuit 11. Work. Huh. No, let's read the code. It's not a long code. Maybe it's just and then again, look. So this is what it does. It only jingled maybe. That's why. And I don't think this one has. Okay, maybe the input would be to put in voltage in it. That's what it says. But let's see how I put the sound. And you have to. What's that?
Yeah, I know.
The Dylan.
Yeah, we'll make a video. I know.
Dito samsamin po sing.
No, we'll record a video about our discovery. I'm not going to take it apart.
It doesn't work for now, but we don't have more time, so we'll.
This here one is called the relays one. So what's special about this one is that it has a relay, and you control it by a magnetical switch. In this you have a relay, a transistor, a diode, 330 ohm resistor, 2 of them, and 2 LED lights, and 14 wires. So what about special about this one is that you like hear clicks and you see that 2 LEDs alternating, illuminating at 1 second interval. So it changes between the red one and the yellow one at 1 time each. The shift register is a parallel serial to parallel converter, and it gives us additional 8 outputs with only three pins, and it is very practical. This is an LED circuit, and that is the LCD screen. And you can see the words "Hello World" in seconds there. There's a potentiometer there, and there are lots of wires. What it does is that it basically says "Hello World" and it counts the seconds.
But this is like a soft fence, it's maybe the softest touch.
That's a potentiometer.
So when it doesn't turn off, it's always on.
See, when you turn it, it turns off, and then turn it off.
And when you turn it, it turns the screen brightness up, and when you turn it lower, it turns it off. You can't see it, so it's like hard to see it. It's very hard to see it because of light and reflection. But it's clearer when it's there. No, wait, there. Yeah.
Kind of. Are you finished talking about it?
Yep.
We don't have to do.
We didn't get to do the last circuit, which is called Simon Says. It's circuit number 16 because when we looked at examples under SIK code, it only went up to 1 to 15, so we couldn't do it.